Look at a great circle question where we're going between hemispheres. So we're going from Cape Town to New York. So I've done this quick sketch here. Here P for the southern pole. We're going from Cape Town all the way to New York. And PA should always be the hemisphere that you're starting off in. And then PB, of course, will be New York. And we have to find the distance, the final course approaching New York, and the northern vertex and the longitude and course as the great circle passes the equator. So obviously our first thing we have to do is work out the values of PA and PB, and of course PB we add to 90 degrees because it's in a different hemisphere. So we get the three values and do the usual formula, and we can work out our total distance. Then we're asked for our final course. Now the final course will be named the same as the hemisphere that we're going to end up in. So it's named north, and of course we're going west. So putting the values into the formula, we find that our course is 296 true. This will tell us that the vertex has to be after our final position, because our course, we're going 296, we're going in a northwesterly direction, and therefore the vertex has to be after the final position. So working out the vertex, I've drawn the wheel, and in green here I've circled the values that we know and the one we're looking for. So sine PV is the complement of the two cosines opposite, which of course changed to sine. Then we can find the latitude. The longitude, again, we'll use PB and B that we know when we find P, and I've gone through the different steps there to get the value, and vertex is after the final position, so the longitude will be 7350 west plus the value of 3648. So the course there indicates to us where the vertex is, and you can see it's after our final position. The vertex will cross the equator at longitude 11038, which is the vertex longitude, minus 90 degrees. It'll cross it at 2038. Of course the latitude, northern hemisphere and southern hemisphere will be the same, but it crosses at 90 degrees less our vertex value. And the course at the equator, of course, will be the vertex latitude taken from 90 degrees, named quadrantially. So we're going northwest, so it would be 90, latitude minus 90, which is north, 43.1 west. And of course the 43.1 is the value taken from 90 that we got with our vertex latitude. And then I've just done there quickly the ETA, but it was more looking at, for this example, more looking at a vessel going between hemispheres and how we would name PA and PB, and how the relation of our course that we've calculated is to the vertex, in other words indicating whether it's before or after the position.